Just a second. I'm so sorry for this is happening. There's some sort of a network issue. It's constantly happening now. Can anybody just check if it is visible?
It is visible.
Okay, I'm so sorry, guys. Fine, so we discussed enough about rules-based approaches and we discussed about the machine learning space as well. So let us move forward to the machine learning process, how it works. Yeah, so the machine learning process, first of all, you focus on the user, what your user wants. Then you define an objective. If your user wants to identify people in a picture, so you are going to define the objective as identifying people in the picture. And after that, you are going to collect data. You are going to take pictures from the user and you are going to train that model. You are going to train and test the model through that data. And after that, you predict and evaluate. Now you will feed in unseen pictures and then it will, the system, the machine learning model that you just trained, it is going to identify by itself how it looks. All right. So, and there are two arrows, if you guys see, there are two arrows which show that the predict and evaluate is going back to collect data and the predict and evaluate is also going back to focus on user. Why is it happening? That is where the experience part comes in. So the machine learning model, it learns with experience. So it begins with the needs of your user and business, and it comes back to the needs of your users because you need to you need to articulate your goals according to the metrics as well, according to what your user needs now. Maybe there is an updation of the demands from your user, so you need to take care of that as well. So you need to retrain your test model. So that this is an important part. This shows the iterative nature of ML. You will need to refine your model and perhaps your data collection as well, and the processing is based on that. So the collecting, cleaning, exploring and other data processes, it is also constant in some way because of the iterative nature that machine learning holds. This
Let's
is
play a game.
another video.
Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the other.
I don't know if it's audible or if the video is visible. So I'm going to anyway paste the link to this YouTube video in the chat box. I'm going
Now
to
imagine that you're trying to
put the link there.
keep losing it to your own bias.
All right. So I'm going to paste the link in the chat box. Just a second. I'm going to do that right now. So you guys can visit this video. I personally like this video a lot because it is very explanatory about the machine learning process. It is going to help a lot. Okay. All right. So I again lost the network connection. There is a serious problem with my network right now. I don't know what is happening. It was working nice and fine, but since it is my first workshop, the network is also playing games with me right now. So I'm again very sorry for what just happened. I am going to transfer this call to Ayush now because my network is not working well. So Ayush is going to take over from here. Ayush, you there?
Yes, I'm there.
Yeah. So you just take your time. Meanwhile, I hope it works and I'll try. But as soon as I lose my connection again, you just take over. Okay.
All right.
Cool. I have enough apologies for you people. So yeah, and thank you for holding up for so long. Okay. Moving forward, what can ML do? This is one very explanatory example, I believe. Artificial intelligence is having a subset called machine learning. Machine learning is having another subset called deep learning. So, in artificial intelligence, a specific field is machine learning, and a specific field in machine learning is deep learning. So, how these three differ? I'm going to talk about this for a little while. So, artificial intelligence is defined as any technology which appears to do something smart because it says the name itself, it is artificially intelligent. So, this can be anything from programmed software to deep learning models which mimic human intelligence. Machine learning is a specific kind of artificial intelligence, but rather than a rule based approach, the system learns how to do something and makes patterns of what data you feed in. This is how much that works. This is how machine learning works. It is a specific field of artificial intelligence. Moving on, there is deep learning. Deep learning is a specific type of machine learning. So, artificial intelligence is the super set of deep learning. Deep learning is specific type of machine learning in a very specific type of artificial intelligence. So, using this technique known as neural network, which connects multiple models together to solve complex types of problems. Deep learning, similar to other machine learning models, learns via examples. As machine learning learns through examples, this also learns through examples. I'm really sorry for that, Bhupat. So I think I have explained my part. So from here, I usually take over. Ayush, you there?
Yes, I'm there. Is the screen visible, guys?
Yep.
All right. Just a second. Hello, everyone. I am Ayush Dhingra, and I'm AI ML co-lead at DSC RTU. I'm currently pursuing my bachelor's in information technology from Rajasthan Technical University, Kota. And now we'll dive deep into neural networks in our Explore ML part. So let's begin. If you have read anything about machine learning, you may have come across a term named neural networks. They are quite a popular choice for machine learning models because of their ability to solve and handle complex problems and talking about neural networks. Well, since the start, we are trying to imitate the problem solving capabilities of human brain, and brain has neural networks, so we call them neural networks. And to understand it better, let's watch short video. There's any All right, here's the link, guys. So let's see.
Ayush, I think the audio is off for the video.
Sorry? Audio?
There's no audio, I guess.
Just a second.
Hi, I'm Nat.
And I'm Lo.
And this is our 20% project, where we go find out about different Google stuff we're curious about. Last year, we got to make a documentary about how voice search works. And that was the first time we heard about something called machine learning. Since then, we've been kind of fascinated by it. So today, we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it. But for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters. When you go to the ATM and you give a check and it can read the handwriting. Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos, here are all my dog photos, here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. So researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn. But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything it can classify as? And suddenly you can go and ask, neural net, what do you think a cat looks like? And you get a picture of a cat. Or, neural net, what do you think a barbell looks like? So these weights. And it goes and it shows you a picture not only of a barbell, but of an arm attached to a barbell. So the model thought that the arms, it only learned what barbells were from looking at pictures of barbells, and they're often held by muscular weightlifters. And so it learned that there was, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, you say to a kid, that's a filing cabinet. And then a second later you say, what's that? Yeah. He's not going to be like, shoe, right?
Well, like, the more you describe this, the more I'm amazed by human beings.
Yeah.
The effect is like, wow, human beings are really amazing.
We're really amazing learning machines.
All right, that was quite an interesting video. So what was all that about? We saw neural networks. What are neural networks? Neural networks are just complex mathematical functions that act upon input. They map the input with the output, right? And what can a neural network do? Well, they can solve pretty complex problems. So yeah, here we see a model, a neural network model, you can say, and the dots are all neurons. In the introductory module, Iman told you that there are a couple of types of machine learning models, such as classification and regression. If we have simple problems, they can be solved with simple models. But when we bring in audio files, video files, image, and even numerical data with lots of variables, we need to have something which is capable of solving their problems. We need complex models. And well, in reality, neural network is nothing like that. This is just to make you understand how they actually work. Okay, here we are training, we are trying to train a model by feeding it images of dogs and images of cats, right? We are training. We are telling it that this is an image of a cat. Now learn from it, so that next time when someone shows you an image of a cat, you know it's a cat. And these are all layers of neurons. This is the input layer. This is the first which interacts with the data. And well, here we come across a meme. Wait a second. All right. You guys might have seen this meme. Just a second. Yeah. People with no idea about AI saying it will take over the world, and my neural network says this cat is a dog, right? So a model is as good as the data it has been trained with. Okay, so if we given the data only pictures of a cat, if we show it a dog, it will probably say yes, it's a cat. It has never seen a dog. So, well, we saw how neural networks work, but let's understand how they work and how they learn. So this is, you can say, this is a neuron, and it looks a lot like an if-else condition, right? There's a condition, and if yes, then do something. If no, do nothing. So what is an activation function? Well, activation function is a threshold or a requirement, and if the input satisfies or fulfills that requirement, then it activates the neuron. What does it mean by activating the neuron? Well, by activating the neuron, it means that neuron passes a signal to the next neuron. And if the condition is not met, than do nothing. Okay, and let's look at some examples to understand it better. Here, the activation function checks if the input is less than 10. The number 5 is the input to this neuron. The neuron's activation function has learned to check if a number has less than 10 or not. And here, yes, 5 is less than 10. So it activates the neuron, passes on the signal. This is one of the simplest forms of a neural network. It's effectively the same as a linear regression or fitting a line into a data. Let's see one more example. Here, the neuron has learned to identify curves, and we are giving it the image of a number 7. So it checks, has the image a curve? Well, no, 7 doesn't have any curve. So do not activate the neuron. The input does not have a curve. So it fails to pass the test, and so the neuron is not activated. But how has this neuron learned to understand if an image has curve or not? We'll see. Here we pass an image of 6, which has a curve. We know. And yes, it activates the neuron. The test is passed. Well, simple functions like these combine to make more complex decisions. Like this neuron alone cannot find out if the image has a curve or not. The neurons previous to this told that yes, this pixel is on, this pixel is on, this pixel is on. So if the certain pixels are on, then yet it must be curved. So it's just like the transistors in our computer, right? They can do only 0 and 1, but we combine a lot of them together, and then we can do many things, many powerful things, right? So, and well, this calls for another meme. Tech companies seeing if condition, is this machine learning? Well, this sort of looks like a machine learning. This sort of looks like an if condition, right? So, but it's not. And what have we learned so far, right? We have learned that what are neural networks? Their ability to solve complex problems, their ability to solve complex situations and handle complex data. We saw what are neurons, and we'll further see how neural networks work. We'll play with TensorFlow for a bit, and but that's it for today. If you guys have any question, you can shoot out right now in the comment section or turning on your mic anyway. Anybody? Come on, guys.
I guess nobody has a question. Like they are all
Seriously?
intelligent people.
समझ में नहीं
They
आया क्या?
understand everything. सबका सब समझ में आ गया. Anyone, Pranjal? You got a question? Nidhi, Vijay, Chris Matha.
Cool.
Good.
Okay.
All right. So that was okay. What is a neuron? Pradyum Dave asked a question. What is a neuron?
Oh, well, neuron, you can say it's a simple entity which performs a mathematical operation. It acts on a certain amount of input it has been given and makes some decision upon it.
Well, you can also say that neuron is something which is sensitive. That's it. It senses. Suppose a neural network, you give it a picture, so it is going to sense what all pixels are activated. That's what neurons are all about, I guess.
Right.
Yeah. So I would like to thank all of you guys who did stick till the end. Mihir, Krismitha, Himanshu, Faizan, Pradyum and Singh Sisodia, Pranjal, and of course Shafiq and Sanjoy. Sanjoy and Shafiq, you guys were active. Thank you so much for being there. Even Pranjal was exceptionally active. Thank you guys. Thank you, and see you at tomorrow's workshop. Bye, Ayush. And bye,
Bye,
everyone
guys.
else. Thanks, Sanjay. Thank you, Krishnata. Thanks, Nihir. Of course, Shafiq, every time, anytime. Tomorrow as well. See you in tomorrow's workshop. Yes, Satyam, tomorrow at the same time. Thank you so much, Sanjoy. I Captain Mihir flips hair. Mihir, should I play some Nusrat Fateh Ali Khan now? Oh, bye, guys. Bye, everyone.